We now turn to the other two models that we mentioned in the previous video, namely the chain of causation model and the necessary component and sufficient causes model. Remember, I pointed out in the previous video that there's a lot of overlap between these different models. They're not mutually exclusive. Now, according to the chain of causation model that explains causation of diseases, a disease has several causes that either together or separately give rise to the disease. One cause can also contribute to the origin of several different diseases. We pointed that out in the previous video, if you remember. Unfortunately, each of these causes is also influenced by other factors. And so the causes of disease are also interacting between themselves as well as with the host. And when you put all these things together, it gives a very complex causal chain. This diagram with arrows just shows the complexity. You see the associations and the causal or influential pathways can work in all sorts of both directions or just in one direction, but the net effect is a person becomes diseased. Now, these different factors could be biophysical, social, environmental, psychological, genetic, and some might inhibit disease, they might protect us, others might make us more vulnerable. So, but the prevalence of the disease depends in the end on the prevalence of these associations, these causal factors. So here is a causal chain that someone has published to do with myocardial infarction, which you might know by its common name of heart attack. You see, these chronic disorders are often very, very complex in terms of their causation. You see people with heart attacks, it's influenced by personality, by emotional, by cigarette smoking, by lack of exercise, by hereditary genetic factors. This is quite common in some parts of South Africa. Dietary habits, all sorts of things. The co-prevalence of comorbidities such as diabetes or hyperlipidemias, high blood pressure, and so on and so on. It's very, very complicated. Just in case the previous slide discouraged you, here's a simpler chain of causation, and this one is for asthma. You see it's influenced by genetics, by environmental factors, by the interaction of the gene and environment, and so on. All these can contribute to whether or not one gets asthma. And then if one doesn't have access to care or appropriate care, one actually goes on to get very severe asthma. Now, you could ask, why do we make life so complicated? Well, you know, if you look back at many of those causal factors, especially for the myocardial infarction, many of them can be modified or prevented through interventions. And, you know, there's a huge burden of disease, of heart disease in our country. And as demographic change and lifestyle change takes place and people get older and they change their lifestyles, it's becoming more common. So this produces a huge burden on the individuals, their families, and on society. If we can prevent it, well, that's a good thing. We turn now to the sufficient, necessary, and component causes model. So this is a different model, a different way of explaining it, but you'll see that there are many overlaps with the two previous models as well. So it's right, we look at the situation as a sort of a piece of cake or a pie, and each different component that influences the outcome is called a component cause. You can see them here, they're labeled A, B, C, D, E. Those are the different component causes, and together they're called a sufficient cause. The sufficient cause is a set of components that is sufficient to be able to produce the disease. And if you find for different sufficient causes, different sets of components that can all produce disease, if there's one feature that's common to all of them, then that becomes a necessary cause. We'll just go through all this again. A necessary cause is one of the components that must be present Without it, you cannot get the disease. If you don't have M. tuberculosis in your lungs, you cannot get lung TB. So it must be present in every case of the disease. Sufficient cause is a set of minimum conditions or events that inevitably result in disease. And of course, one of those components must be the necessary cause if there is one. And some examples here: in salmonella outbreak, that's food poisoning, either eating the chicken or the pudding were sufficient causes. Presumably both were therefore contaminated with the salmonella organism. For TB, there are many different components that influence the cause of TB, but M. tuberculosis must be present, so that's a necessary cause. It's rare for a single factor to be both a necessary and a sufficient cause on its own, but it can, of course, happen. A component cause is any one of a set of conditions that are necessary for the completion of a sufficient cause. So it doesn't necessarily include, or it doesn't include the necessary causes. These component causes are in addition to the necessary cause. They add to the necessary cause. So it's the additional slices of pie that together with the necessary cause result in the disease. So here we have an example where you can practice and see if you've understood the difference between necessary, component, and sufficient causes. These three pies represent different sets that result in tuberculosis disease, TB of the lung. So A might stand for infection with M. tuberculosis, which is the organism. B might stand for infection with HIV. C might stand for diabetes, and so on. Now, can you identify the necessary cause? Can you identify some component causes? And can you identify the sufficient cause or causes? We'll give you a bit of time to do this, just a few seconds, and then we'll move on to the solution. So here we have the answer. A, the presence of M. tuberculosis, is present in each set, and it's the only one that's present in each, so that must be the necessary cause, because you can't get TB without that. All the other slices are components in that they contribute, but they're not necessary. You see, some are present in one pie, but not in another pie. Some are present in two pies, but not in the third, and so on. Each of the three sets is a sufficient cause, because it's a cluster of component and necessary cause that is sufficient to cause the disease.